Welcome to this section on the determinant of 4 by 4 matrix. To determine the determinant of the 4 by 4 matrix, we have to choose any one of the 4 rows or the 4 columns as the coefficient of the 3 by 3 matrix we are gonna form, and we have to express the Kildin matrix as the sum of 4 3 by 3 matrices. In order to shorten the steps we are going through, it's recommended to choose a row or column with greater number of zeros as the coefficient of the matrices we will form. As an example, let's find the determinant of this 4 by 4 matrix. In the given matrix, we can't find any row or column containing more than 1 0, but 2 rows and 2 columns are on type with 1 0. So we can choose either of them as a coefficient. For this particular case, let's choose row 2. To find the sign of the coefficients, we have to assign plus and minus signs alternatively down column 1, starting from row 1, column 1 entry. That is, the sign of the first entry is positive, the second entry is negative, third entry is positive, and fourth entry is negative. Once we discover the sign of the first element of row 2, we can simply assign negative and positive signs across the row alternatively. That's the first element is already determined as negative, second element will be positive, third element will be negative, and the fourth element is positive. So let's form the addition by using row 2 elements as a coefficient. Determinant of matrix A equal to, the sign of 4 is negative, so negative 4 times the determinant of the first 3 by 3 matrix. We will discover the elements of the matrix later. For the time being, let's simply form the skeleton of the addition. The sign of the second entry is positive, so plus negative 2 times the determinant of the second 3 by 3 matrix. The sign of the third entry is negative, so minus 0 times the determinant of the third 3 by 3 matrix. The sign of the ultimate element is positive, so plus negative 3 times the determinant of the fourth 3 by 3 matrix. The elements of each of these 3 by 3 matrices can be determined by crossing out the row and column where the coefficient belongs. 4 is located at the intersection of row 2 and column 1. Crossing out row 2 and column 1 left us with 3, 2, negative 1 in row 1, negative 4, 3, 0 in row 2, and 1, negative 3, 4 in row 3. The row and column associated with negative 2 are row 2 and column 2. When we eliminate them, we will find 1, 2, negative 1 in row 1, 2, 3, 0 in row 2, and negative 2, negative 3, 4 in row 3. 0 is located at the intersection of row 2 and column 3. When we remove row 2 and column 3, we will have 1, 3, negative 1 in row 1, 2, negative 4, 0 in row 2, and negative 2, 1, 4 in row 3. The row and column associated with the last element of row 2 are row 2 and column 4. Crossing out these two, we will find 1, 3, 2 in row 1, 2, negative 4, 3 in row 2, and negative 2, 1, negative 3 in row 3. Now, we can find the determinant of each of these 3 by 3 matrices, and then we can add them. The determinant of the first 3 by 3 matrix is equal to, again, it's advisable to choose a row containing 0 as the coefficient of the 2 by 2 matrix we are gonna form. So row 2 is advisable in this case. As usual, let's assign positive and negative signs alternatively for each of first column elements starting from row 1, column 1, meaning the sign of 3 is positive, the sign of negative 4 is negative, and the sign of 0 is positive. Since the sign of first entry of row 2 is negative, the sign of second entry is positive, and the sign of third entry will be negative. The sign of negative 4 is negative, so it will be minus negative 4 times the determinant of the first 2 by 2 matrix. The sign of 3 is positive, that's plus 3 times the determinant of the second 2 by 2 matrix. The sign of the third entry is negative, so minus 0 times the determinant of the third 2 by 2 matrix. Negative 4 is in row 2, column 1. Removing these two, we will find 2, negative 1 and negative 3, 4. 3 is in row 2, column 2. Removing row 2 and column 2 left us with 3, negative 1 in the first row and 1, 4 in the second row. 0 is located at the intersection of row 2 and column 3. Crossing out these two, we will find 3, 2 in row 1 and 1, negative 3 in row 2. To determine the determinant of 2 by 2 matrix, we have to multiply the main diagonal elements, and from this product, we have to deduct the product of the remaining two elements. That's minus negative 4 is plus 4 times 2 times 4 minus negative 3 times negative 1 plus 3 times 4 minus 1 times negative 1 minus 0 times any number is simply 0, which is equal to 4 times 2 times 4 is 8 minus negative 3 times negative 1 is 3 plus 3 times 4 is 12. 1 times negative 1 is negative 1 minus negative 1 is plus 1, which is equal to 4 times 8 minus 3 is 5 plus 3 times 12 plus 1 is 13, which is equal to 4 times 5 is 20 plus 3 times 13 is 39. 20 plus 39 gives us 59. So this first expression becomes negative 4 times 59. When we come to the second 3 by 3 matrix, again it's advisable to choose second row elements as a coefficient of the 2 by 2 matrix we are gonna form because it contains 1, 0. Just like the first matrix, the sign of this coefficients is negative for the first entry, positive for the second entry, and negative for the third entry. So their sum becomes negative 2 times determinant of the first 2 by 2 matrix plus 3 times determinant of the second 2 by 2 matrix minus 0 times determinant of the third 2 by 2 matrix. 2 is in row 2, column 1. Removing these two, we will find 2, negative 1 and negative 3, 4. 3 is in row 2, column 2. Crossing out these two left us with 1, negative 1 in the first row and negative 2, 4 in second row. The third coefficient is 0, so we need to determine the elements of the matrix because 0 times any number is simply 0, which is equal to negative 2 times 4 minus negative 3 times negative 1 plus 3 times 1 times 4 minus negative 2 times negative 1, which is equal to negative 2 times 4 is 8 minus negative 3 times negative 1 is positive 3 plus 3 times 1 times 4 is 4 minus negative 2 times negative 1 is positive 2, which is equal to negative 2 times 8 minus 3 is plus 5 plus 3 times 4 minus 2 is 2, which is equal to negative 2 times 5 is negative 10 plus 3 times 2 is 6. Negative 10 plus 6 is negative 4. So the value of this expression is plus 2 times negative 2 times negative 4. The coefficient of this 3 by 3 matrix is 0. So no need to calculate the determinant of the matrix because 0 times any number is 0. That's why we choose this row 2 elements as a coefficient. For this last matrix, the determinant is equal to none of the rows or columns have 0. So we can choose either of them as a coefficient. For this particular case, let's choose row 1. The sign of row 1, column 1 entry is positive as usual. The second entry is negative and the third entry is positive. So the sum becomes 1 times the determinant of the first 2 by 2 matrix minus 3 times the determinant of the second 2 by 2 matrix plus 2 times the determinant of the third 2 by 2 matrix. 1 is in row 1, column 1. Removing these two, we will find these 4 elements. 3 is in row 1, column 2. Eliminating these two, we will find 2, 3 in row 1 and negative 2, negative 3 in row 2. 2 is in row 1, column 3. Closing these two out, we will have these 4 elements, which is equal to 1 times negative 4 times negative 3 minus 1 times 3 minus 3 times 2 times negative 3 minus negative 2 times 3 plus 2 times 1 minus negative 2 times negative 4, which is equal to 1 times negative 4 times negative 3 is positive 12 minus 3 times 1 is 3 minus 3 times 2 times negative 3 is negative 6. Negative 2 times 3 is negative 6 minus negative 6 is plus 6 plus 2 times 1 is 2 minus negative 2 times negative 4 is 8, which is equal to 12 minus 3 is 9. 9 times 1 gives us 9 minus negative 6 plus 6 is 0. 0 times 3 is 0. 2 minus 8 is negative 6. 2 times negative 6 is negative 12. 9 minus 0 is 9. 9 minus 12 is negative 3. So the value of this last expression becomes the coefficient, that's negative 3, times the determinant we calculated, that's also negative 3. At this stage, what we left is simple multiplication and addition. Negative 4 times 59 is negative 236 plus negative 2 times negative 4 is positive 8 plus negative 3 times negative 3 is 9. 8 plus 9 is 17. Negative 236 plus 17 is negative 219. You can check the correctness of the answer by using online determinant calculator, that's Wolfram Alpha. By this, I conclude this section. Thank you for your attention. Stay safe.